It is time once again to revisit PCG Extreme and actually go over pathfinding and some path things and show you guys how to use them, what they are, different nodes you should be aware of. Using pathfinding, we're able to create something like this, where we have gone from one point to another, and we can even customize it to go through a different location really quick and easy. And you can see it adjusts the entire road that is using spline meshes, and it spawns lampposts equidistance apart. And not only that, but they're all facing the correct direction relative to the actual path. And all of this is possible thanks to PCGEx, and not only is it possible, it is very simple to do. This tutorial is definitely geared toward the people that are just getting started with PCGEx, so you kind of understand how the pathfinding in PCGEx is different than the one in the original, as well as some general path node things using the PCGEx nodes that I think are really cool. So let me teach you all about them. Now, in my case, I am in 5.6, but either way, you will need to go to Edit Plugins, search for PCG, and make sure you have PCG Extended Toolkit installed and enabled, as well as the PCG plugin as well. And then go ahead and just restart your engine if needed. So to get started with everything, let's go ahead and make ourselves just a regular PCG graph. We'll use an empty graph here. I'll call it PCGEx underscore pathfinding. And I'll go ahead and just drag down to the world and then open it up. So the way pathfinding works is it uses clusters. Now, I covered clusters in the previous video, but I'll still go over a new cluster type that I didn't cover last time, so you still have an understanding how to use the basic clusters, how to create one, and how that kind of works, as well as some new nodes for that. And I'll show you then how to set up the pathfinding and then what to do once you have the pathfinding path. So let's go ahead and create a cluster. For the cluster, I am just going to use a create points grid for our source. I'm going to want a lot more points, so I'm going to change the cell size of the create points grid node to just 50 in the X and Y. The Z doesn't matter because we're not doing a vertical thing. But from here, we can already just drag out and grab ourselves one of the new nodes, cluster Delaney 2D. We're going to grab that one right over here, and immediately we can just drag out of VTX for vertex and search for debug edges and plug both of those in here. And immediately once we do this, you'll see there's our grid and there's the actual setup. Now, it might look like it's just every point gets a square with a random angled triangle. And in this scenario, that is the case. But watch what happens when we add some variation between create the points grid and the actual cluster node. If we go ahead and add a transform points node, and here I offset them from -50 in X and Y to +50 in X and Y, and just have that right between, you will see it becomes a little more interesting. Now, already, theoretically, you could use this for pathfinding, but you don't want to have too many points. It's really not needed. So what we can do is some nifty things. On this Delaney 2D node, in the settings here, you'll see another name that is hard to pronounce. Urquhart. Look, I'm gonna have to excuse myself on all of these pronunciations. I don't understand them, but thankfully, if you hover over it, you do get a description, which basically, in parentheses, says, removes the longest edge of each cell. Perfect. We'll turn that on. And when we do that, you can see it has gone ahead and removed the longest edge. Now, if I go ahead and just toggle it on and off so you can see, on every single triangle, it is removing the longest edge. So effectively, we're just left with the two shortest paths. Now, this does result in a little bit of these kind of edges that are kind of sticking out. Maybe you want to have just the entire interior to have a nice kind of closed setup here. And don't worry, there's a node for that. The node is simply cluster simplify. I'll go ahead and move the debug edges right in between here. We'll plug vertex into vertex, edges into edges, and same thing here. And on the simplify node, we want to do a few things because we want to get rid of just these section here. And these are called leaves. So if I want to get rid of these that are sticking out over here, then I just want to operate just on leaves. So on the simplify node, I'm going to turn on operate on leaves only. And then you'll see prune leaves as a checkbox. Go ahead and check that on. Now, you'll see that almost all of them have gone except this one right here. And why is this one here? Well, if I turn prune leaves, you'll see why. It has pruned these two, which has made another actual leaf basically here. So again, if I turn it on, you can see it removes every single other one except this one. Unfortunately, it does not repeat itself until all leaves are gone. So in this scenario, if I'm happy with the setup, I could just use another cluster simplify, exactly the same one, and then plug everything through. And now you'll see on this one, that little piece is now gone. And we're left with just this nice random cluster of different paths effectively that we can use. Now to make it a little bit easier, I will just change the material on the ground here. So it's a little bit easier to tell of what the path is. There we go. So now it should be a little much easier to see. So fantastic. We now have this cluster. We can now get from one point to another any way we want. So this is where the pathfinding comes in. Now, of course, we need a start and end to pathfinding, just like in the regular pathfinding setup. So I'm going to just add something to the viewport. I'm going to search for target to get a target point and place it like around here. And then I'm going to search for tag in the detail panel and add ourselves a tag here. This is going to be start. And I'm going to add another one at the end here, and I'll call it end for the tag. So now we have a start and an end. Fantastic. So let's go ahead and create our path, the first one. For that, all we need to do is search pathfinding. Now we have the pathfinding generic one from regular PCG. If you want the ones that are PCGEx, we'll be going with the pathfinding edges in this scenario. And again, vertex to vertex, edges to edges. And here you need seeds and goals. Seeds are basically the starts and goals are the ends. Now you might notice that they're plural. You can have multiple starts and multiple ends. And I'll actually show you what happens when you do. So we first need to put in the seeds and the goals. So I'm going to right click, get actor data. Now we want to change the mode here to get single point and merge simple data. In case we have multiple, we want to get all of it as one piece of data. The actor filter will be all world actors by tag. It will be start, and we will turn on select multiple. So we grab multiple in the world if we need to. This is going to go into our seeds, and I'll duplicate the get actor data and change the tag here to end. And this end one will go into the goals. Now, immediately it throws you an error. No operation selected for goal picker. And that's because in our actual pathfinding edges node, we haven't set up anything, specifically the goal picker. Over here, you'll see all default index attribute and random. Now, at the current moment, random is broken. Tim is aware of it, so it should be fixed in a future update. So for this demonstration, I will just show you all so you can really see how every connection can get connected to everything else. So we'll go ahead and choose all. I definitely recommend playing around with these settings when you do it for yourself so you really can get an understanding of what every setting does. Now we have picked a goal picker, but there's still an error. Well, the new one is no operation selected for search algorithm. So now it's asking for a search algorithm, which is right here. We can do A star, which is the default pathfinding that you have in PCG. And you also have this one. Now, from my experience testing it just a little bit, I didn't see any difference, so feel free to pick either one. You could try out both and see which one works better for you. Effectively, they're both going to go from point A to point B. The only difference is the algorithm that it uses to get there. At this point, again, there's still an error, missing heuristics. So that is the final thing we need to plug in. So if I right click and search heuristics, you'll see we have quite a few things, and one of them is shortest distance. So if we grab shortest distance heuristics here, and you can play around with choosing a different one as well for yourself and plug in shortest distance, we now have this node fully configured, no more errors. So because it throws out a path here, I'm going to just go ahead and search for debug paths node, and I'm going to change the parameter overrides of the debug paths radius to be something like 5. And if we take a look, you could see it is now going from the start to the end along the cluster all the way through. And if I want to, I can change the start to be anywhere else. Now here's the thing. We made it so we selected all. So that means from every start to every end. So if I take this end point and I held Alt to duplicate around and I move it over here, you'll now see we now have two. We have two paths, one going left, one going right. And that also works if I have multiple starts. If I get a second start, I now have a second one all within the same node. I now have this point that goes to every single end, and this point goes to every single end. And in the same sense, the end ones go all the way to the starts of both. You can play around changing the goal picker to index attribute, for example. And if we go up here in settings, we could change the goal count to be a single attribute and plug in an attribute, for example. You have a lot of controls, but I'll leave that for you guys to play around with and experiment. Now, this has been the pathfinding edges node, but there is one other node that I really want to show off here, and that is the other pathfinding. But instead of pathfinding edges, I'm going to show you pathfinding plot edges. So just like the one above, I'm going to plug in the vertex into vertex, edges into edges. It's going to use the same heuristics, but here I'm going to want to specify every single point. Now, because these are target actors, I just go by class. You can absolutely keep it by tag, but I'll show you what happens when you do it by class here. So we'll do get actor data, change it again to get single point, merge simple data. Under actor filter, all world actors by class, and class is target point. And we want to make sure select multiple is turned on, and that is going to go into plots. Now, just like the other one, it immediately throws an error. No search algorithm. So let's go ahead and select it. And in the search algorithm, I'll go ahead and just select one of them. Now it is no longer complaining, and I'll go ahead and debug the points here. And you can see this one is going to both of the others. Now, is it actually? Because realistically, it's not. If I move this here, you'll see that the paths doesn't really change over there. Well, if I move this right point, let's say over here, you'll see what it's actually doing is it's going from the first point to the second point, and then to the third point. So if I move this third point over, you'll see it has now gone from point 1 to point 2 to point 3. And if I make another copy here, I can get a point 4. So now I can get a more customized path of going through specific areas. And these are outside of the bounds of this area. I can absolutely put this specifically through right here. And now it'll go right through this point and continue on. It is basically like when you use something like Google Maps or any navigation and you're able to add like a little pit stop somewhere. It'll still find the shortest path, but it'll just add that pit stop along the way. And if you'd like to, in this plot edges node, you can specify that it is a closed loop. And when I do that, you will see now the last point here connects all the way back to the first one, just like that. So we can now have a full path going all the way around from the first one to the last one. So that's a very different way than just regular pathfinding that goes from like first and ends. Maybe you want to have it go from a single point to another, to another, to another, and create a full connected path. This might be a good way of doing it through pathfinding. But now let's say you're happy with this path. This is what you want, but now you want to use it as a spline potentially, or convert it to a spline later to use for something else, maybe to spline some spline meshes. It's just a little bit too dense. It's a little bit too jagged because of the cluster you used. So let's tweak it a little bit and show you some fun path nodes. For this example though, I will go ahead and use the plot edges and turn off closed loop. And then I will just configure the spline to be a little bit more interesting here by just doing something like this. So you can see it is going from here over on the left. We'll actually have it go just a little bit over here. Let's say from over here, it'll go through this area and then go all the way up, just like that. Let's say this is the path that I wanted to take. So what can we do now with it? Well, the first thing I want to do is simplify this. This is too jagged. If I was to convert it to a spline, for example, to either spawn something or potentially just use it as a spline later on as a component, I don't want all these very hard jaggedy edges, so I'm going to smooth it out. There's kind of two ways of doing it. You can even combine the two, so that's what I'll show you. The first one is using a simple path smooth node. So we'll just grab a path smooth node. I'll, again, plug the debug here at the end so we can see what's going on. In the settings here, we can change the smoothing method. So we'll change it to either moving average or radius. Moving average, I found, works really nice for what I want. And then down below here, you can see smoothing. Now, what basically smoothing is it looks forward and back for that point, and how many points forward, how many points back do you want it to smooth effectively? Now, it'll make more sense in a second, but one thing this node requires is to plug in a blend operator. So I'm going to right click and search for blend, and you'll see there's a bunch of different blends. Now, don't worry, if you select any of them, it doesn't matter which one. In the actual detail panel, you can always change the blend mode right over here. So there's all your different blends. So for example, if I did by weight, by just selecting weight here, I can specify the weight of what? Well, in my case, I want to blend the position, so I'm going to change the point position. So based on the position, it is going to do something. And that is going to go into the blend ops here. And if we take a look, you can see our spline is now very smooth. It is no longer going very jagged. If I go onto the smooth node and change the smoothing from 5 to, let's say, 2, so it's going to look forward and back just 2 points, you can see it is still maintaining the shape a lot more as it was before, but is now considerably smoothed out. Now, it is no longer going fully to the start and fully to the end, but don't worry, we got you covered. Preserve start and preserve end, check both of those on, and you can see it now goes ahead and connects it all the way to the end. Now, this final point isn't as smooth as the rest. it effectively just extended it to the start and extended it to the end. So it's not quite as clean on these 2 points. Once we finish with this, it won't even matter. So let's keep going. We now have a smoothed, nicer curve that follows the general path here. Let's now reduce the amount of points we have. We don't need that many points to show that this is the curve. We can use far fewer points. So after the smooth node, we're going to use another path node. This is going to be path resample. And as the name suggests, it is going to resample the path. We'll go ahead and plug in, again, our debug at the end here. And on this resample node, it is set to distance by default. So be careful a little bit with this node when you just plug it in, because if you have a very long path, it is going to create a lot of points by default. As you can see, all of these little ball shaped here are all points. So instead, we're going to change the distance here to count. So this entire spline is going to have 10 points. And now you can see it has now smoothed out to a 10-point spline. Now, in this case, we might maybe want a little more. Let's say we want something like 20. We want a little double that. And now we have the original smoothed spline, but it is now a little bit more detailed in its points. Now you can absolutely just ignore the smooth. If I hit E right now to disable the node, this is the result with no smoothing, but using the resample. If I turn on smoothing, you can see it becomes a little smoother in between. No smoothing, with smoothing, no smoothing, with smoothing. Depending on what you're trying to do, maybe a resample is all you need, or maybe you want to keep the information and the amount of points, but you want to just smooth it. You have a lot of options in that regard. If you do want to keep all those points, let's say you don't want to resample, you just want to keep it on smooth, the distance between all of these points isn't equal. And it would be nice when creating a spline for them to be somewhat equal potentially. So don't worry, there's also a PCGEx node for that. And by another node, I mean just the resample node. Over here under mode, instead of sweep, which is what we're using to remake it to 20 points, we can change sweep to redistribute. It pretty much removes most of the settings here. There's still a few left if you'd like, but all it's now done is redistributed all of the points that are currently there and made them an equal distance apart from each other. So in a matter of sense, it has smoothed it out by redistributing. If I go ahead and again, disable it and enable it, you can see how this changes. So the points over here are a bit more clustered together. These are more further apart. And if I re-enable it, right, it all gets redistributed. This sharper corner gets pulled in. It is nicer right here. So depending on what you want, you can go ahead and redistribute or just rebuild the thing entirely effectively with a specific count. Now, the main thing about this path is this doesn't require a cluster. All of these path nodes you can just use with your current points that you're using for a spline anyway. So for example, if you want, you could just create a spline in the world using just a blueprint spline, sample the spline with this regular spline sampler, and then just start using all the path nodes. You're not required to use the cluster and pathfinding to use these nodes. So all the nodes I'm showing you are just ways of modifying the path. Now, in this case, we're modifying the actual pathfinding that we created, but just know you absolutely can use this on just the regular PCG nodes. You're not required to use the clusters. Now, let's say I am happy with this spline. Let's say this is the path that I want. This is the pathfinding that I want. You know what we wanted to do? We want to put a road here. Well, putting a road somewhere is relatively simple. We already have this. We can just use a spawn spline mesh. It will get us what we want. The trick before was once you created a road was to put things on the sides of the road. Because a spline, when you make a curved road, you want to put something to the right and to the left of it, but keep the distance away from that spline equal. And with regular PCG, it's not the simplest thing in the world, but with PCGEx, it is. So again, I'm going to detach this debug paths and we'll continue off of this resample. From the resample, we're going to grab ourselves a path offset because we want to offset the path to the left and to the right. So we'll actually use two of these nodes and we'll plug both of them into the debug paths here. On this top one, I'm going to change the offset by 200. We're going to keep it on the default slide constant. And on the second offset, we're going to change it to -200. And with both of these now plugged into the debug paths node, you will see we now have a path, although it's a little bit wonky. If I go ahead and just duplicate this debug paths, and in this one, in the properties overrides, we'll change the color here to be something like green, and then use the original resample into it, you will see that this was the original path, and then this is what it created. Now we have some issues here, right? Basically what it's doing is it's taking the normals here effectively, and it's pushing out and in. And because of this inner corner, we're getting this mess. Now you absolutely can say, okay, you know what? Then I won't push it out as far. Let's go at 100 and negative 100. The problem is definitely not as bad, but you still see there is a problem. So let's say this is the size of the actual path we want. This is how we want it to go. It is following the path finding that we set up, but now we got to fix this. Because when we spawn actual poles on them with lamps, we don't want this weird little thing. In this offset node, there's a section called cleanup. Now the cleanup mode here is none, but we have a few options. Collapse flipped segments, collapse sections flipped, and collapse sections. If I hover over the bottom one here, you see remove sections of the path that are between self-intersections. So if I go ahead and select collapse sections for the top and the bottom option here, you will see that all of a sudden, the problem area that was here is no longer there. It is now effectively removed it. If I go ahead, undo and redo, you can see that is just the section that has disappeared because it was kind of intersecting itself and it was done a good job of cleaning it up. So if we wanted to, let's go back to the 200 offset in the path for positive 200 and negative 200, and you will see the big mess that we used to have on the road being that wide is now fine. Here's the road and it looks pretty good. Now, if I stop debugging the original cluster here, you will see now as a road, this kind of now makes sense. We now have something we can have in the middle of the road, which is the path, and something we could spawn on the edges of the road very, very easily. Now, if we wanted to, for example, spawn something along this, you could either resample it, or you could even now, because they're just points, use a regular PCG create spline node, create to a regular spline, and then use a spline mesh or something of that sort. Or because we're in PCGEx, we can make use of PCGEx's spline mesh spawning tools to allow us to customize things a little bit. So what we can use is a spline mesh node, but not the regular spline mesh. We want to use the custom ones. Now, there's two, Spline Mesh Simple and Spline Mesh. Spline Mesh Simple allows you to use an attribute as the Spline Mesh in case you added a Spline Mesh attribute before, because the regular Spline Mesh node that comes with PCG still takes just a specific static mesh. It is not as dynamic. But that is the simple version. If you used a non-simple version of the regular PCGEx Path Spline Mesh, this one takes an asset collection. So let me show you how to set up this spline mesh. And we can go ahead and do it off of the original center section here. So I'll go plug it in. It gives us an error because it's missing an asset collection. So let's create one. All I'm going to do is right click, go to miscellaneous, and grab ourselves a data asset. Over here on the top here, you can see PCGEx mesh collection and actor collection. In this case, we want a mesh collection. So we'll go ahead and select it. I'll call it DA_road and just open it up. It's relatively simple to set up. All we need to do is just add an entry here and open it. And I'll go ahead and just plug in a static mesh right over here. Now, the nice thing is here, you can add multiple entries. For example, if I went ahead and added a second one, and this can be just a regular cube, for example, just so we could see what happens when you have multiple. And then we can use it in here under asset collection. We can have it in the drop down DA road, and you can see we have some oddities here. What's going on? This seems like it's very broken. Well, here's the thing. We've created these paths, but their tangents are still of the original cluster that created them, basically. So we need to fix the tangents for this to look proper. So what we're going to do is after this resample, I'm going to move all of these over to the right. I'm going to grab ourselves a path right tangents. Now I'm going to just rehook up basically everything to this one, and we'll put it right in between. Like most nodes, it gives us an error. No operation selected for tangents. And if we look at this detail panel, there's tangents. It's set to none. So we need to change it to something. For example, catmull. We can do from neighbors, from transform 0. Catmull is kind of the default. And once we have the right tangents all set up with this, we just need to use them. So in the spline mesh here, we want to apply custom tangents. We can turn that on. And by default, this arrive and leave tangents, you could see is the same as it is here, the arrive name and leave name. So it's automatically set up for you here. And one thing to note here is at the current moment, the spline acts as a line. All your spline meshes need to face the same way at the current moment. Tim knows about this now, so hopefully in a future version, we'll be able to even customize the forward axis per mesh down the line. But at the current moment, just make sure your forward axis is the same on all your meshes when using these nodes. But with that now set up, if we take a look, you could see it is now following the path quite well. And you can see, because we're using the spline mesh from PCGEx and the asset collection, we're able to randomize which piece shows up. Now, in my case, I don't actually care much for the actual cube, so I'll go ahead and delete it. And I'll go ahead and click Rebuild Staging and a Force Region on the PCG node. And you'll see now we have something like this. Now, while the path itself, as you can see, is quite nice, there's not much it can do when dealing with actual intersection of geo. So just keep that in mind, that even if the spline itself is fine, the geo could theoretically still intersect. But if we wanted to now, let's adjust the actual points here to be closer to the spline location of this actual road. And we'll do that by changing the offset on the offset nodes to 130 positive and negative 130. And then from both of these, I can use a static mesh spawner, just a regular this time, to just show you that we can indeed still use the default regular PCG nodes with all of this. We'll just add a simple entry here, and I have a lamp that I'm going to spawn here. And you can see now we have a lamp spawning all across the spline. Now you can see it is not following the actual path here. We might want to have it follow the path. And just like everything else I've shown, it is indeed very simple to do with PCGEx. There's a fantastic node called Path Orient. So if we go ahead and use that after the offsets here and before the static mesh spawner, as always, is going to throw an error, but that's fine. All it wants is an orientation here. So we'll go ahead and select a look at, and if we open it up, we will say look at the next point. And it is looking at the next point, except it's just sideways. We can also tell it to face a direction. We can even tell it to go to a position if we want all of them to face a specific location. We also have a forward axis, so if we want to, we just change the forward here to be right. And now you can see all of the roofs now are following more so with this spline. Now in our case, this is way too many lamps, right? So again, we can just go ahead and resample these before our look at. We take our offsets, plug them into a resample, then go into the look at. And on this resample, instead of count being 20, we'll say something like 5 to have far fewer. And you'll see now we have this road spawning the lamps along the road, equidistance along it. It is facing the correct way along the road relative to the actual path, and we're in a good spot. Now, this is clearly way too small of an area for this, but now all we need to do is go back to the very beginning on the create points grid, change the grid extents to 2500 instead of 500. So we have now a much bigger area, and now we can take the target points, move it all the way back here, move the second point over here, third one way in the future. And now you can see we now have a much nicer setup here. And because it is currently on count, we still have 5 of these, but on a large scale, of course, you can go ahead back to the resample, change it from count to distance. The distance will be 500. And now look at that. We now have a full road, and all of these on its side, all the lamps here line up where I've positioned them relative to the thickness of the road. So I don't have to do all crazy computations to get it aligned and looking in the direction I want, which I think is really cool. I want to give a big thank you to Tim, of course, for creating PCGEx and helping me with this tutorial and showing me the stuff so I can help you guys learn more about PCGEx. It is an extremely awesome and powerful plugin. The link to his Discord, where you can reach out to the entire PCGEx community, will be linked in the description below, so you can say hi and join the community if you're interested in this. I'm also going to include the project file for this on my Patreon, where you can join these wonderful people here in supporting in what I do. It really means a lot. And of course, the link to my own community will be down in the description as well. And if you missed the last PCGEx tutorial, we went over clusters and different ways of using them. So check out this video right here for some more PCGEx goodness.